Hello everyone, welcome to today's session on Combinatorics. I hope I am audible and visible. Let's get started without any further ado. Before that, let me just brief you guys through TLE 12.0. TLE 12.0 is the 12th batch of TLE Eliminators. What is TLE Eliminators? We provide comprehensive guides to competitive programming, whether you're a beginner or even if you're expert on code forces. There's a lot to learn. We teach everything from STL to dynamic programming, sparse tables, and all those things. So if you're interested, you can go to tleeliminators.com/courses and check our courses out. With that being said, let's start with combinatorics. I hope you guys are excited for the same, right? Combinatorics is a part of TLE level 3, and today we'll be learning combinatorics in detail. Okay, we'll be going through the base of why things are the way they are, and then we'll look further. With that being said, let's get started with today's session. Today's session, guys, is very mathematical and it is developed to build your mathematical base. Okay, so let's get started. Before looking at no, this is not a recorded video, Bharat. It's live. I'll be taking up your doubts as well. With that being said, let's look at what permutations are. And after looking at what permutations are, we'll be looking at what combinations are. Okay, guys, consider that you have numbers 1, 2, 3, so on and so forth up till n. Okay. Now, guys, you want to put them in an array, arrange them in an array of size n. Okay. What do you have? You have numbers 1 to n, each occurring exactly once. All right. And you want to arrange these numbers in an array of size n. My first question to you today is, what are the number of arrangements or what are the number of arrays we can form? Okay, tell me, guys. Okay, Vinny says how to improve rating on code forces. We'll get to all of these definitely in a bit, Vinny. All right. Okay. Ayush says n factorial, Vinny says n factorial, and you guys are absolutely right. The answer here is n factorial. But have you guys ever wondered that why is this n factorial? Why is it not n squared? Why is not n cube? Have you fundamentally questioned this, guys? Do you know how this n factorial comes into play? Have you questioned this ever? Today we'll be questioning this. Why is this n factorial? And the answer, guys, is very simple. Assume that you are building this array. You are in charge. You are in charge and you are building this array. Okay. Let's say we are building up arrays from the first index up till the nth index, and n here is 5. Okay. Now, guys, for the first position, do you agree we can have any number from 1, 2, 3, 4, 5? Yes or no, guys? Tell me. We can have any number from 1 to 5. Yes or no? So can we say we have 5 choices that we can put on the first index? Similarly, once we have put one element on the first index, one of these elements disappear. Let's say the choice we made was 3. It doesn't really matter which choice we made. Okay. After this, for the second index, how many choices do we have, guys? We have 4 choices because we already made a choice and now the remaining number of elements we have is 4. Let's say we removed 4. We put a 4 here. All right. Now for the next index, guys, how many choices do we have? We have 3 choices. And now for the next index, we have 2 choices. And for the next index, we have 1 choice. What I'm trying to say is if we are trying to build the array, okay, First, you have 5 choices. Okay, let me build 5 choices, which is 1, 2, 3, 4, 5. If we expand on this, okay, on the first index, if you had 1, on the second index, now you can have 4 choices, which is 2, 3, 4, 5. And now if you chose 3, you now again have 3 choices, which is 2, 4, 5. And now if you chose 4, you again have 2 choices for the next index, which is 2 and 5. And now lastly, you have 5, and here you have 2. So guys, do you see that we have 5 choices, then we have 4 choices, then we have 3 choices, then we have 2 choices, and then we have 1 choice. So the number of choices or number of arrangements we have is 5 into 4 into 3 into 2 into 1, which is nothing but 5 factorial. And since n was 5, we can just say this is n factorial. Is this much clear for you all guys? Tell me. Is it now clear why the number of arrangements is n factorial and not n cube or n squared or n, right? Is it now clear why it's n factorial? Tell me, guys. Great. Vineet says yes. What about others? Ram says yes. All right. Okay. I definitely will share resources at the end. Zero anime. Don't going. Yes, we would be uh, going through some advanced techniques. Don't worry, guys. All right. Also, fun fact, I'm wearing my Meta Hacker Cup t-shirt because why not? Okay. Now, with that being said, guys, now I have a question for you. Definitely, you can feel free to ask doubts, Atharv. All right. Now, guys, my question to you is, let's say n here was 5. Okay. Which says you have 5 elements, 1, 2, 3, 4, and 5. Okay. Now, let's say you wanted to build an array of size 3. Okay, the size of this array is 3. How many different ways are there to build this array such that these elements can be taken once? So you have elements 1, 2, 3, 4, 5, and then you have an array of size 3, and then you have to build this array. So one possible array is 1 comma 2 comma 3, one possible array is 5 comma 4 comma 1, and so on and so forth. So how many ways are there to build this array? Okay, exactly, guys. So guys, you guys are telling me that it's 5p3, it's 60. Let's verify. All right. How do you go about solving this problem if you have no idea of permutation and combination? We solve this like solving the last problem. Exactly. You have 5 choices for the first position, that is 1, 2, 3, 4, 5. Then you have 4 choices, and then you have 3 choices. So the number of choices just 20 into 3, which is 60 ways. And I think majority of y'all were able to get it right. And this right here, guys, you have n elements and you want to permute them or arrange them into some boxes. Okay. You want to choose some of them. This is nothing but permutations. Okay. This is nothing but permutations, or what we call as NPR, where we have n elements and we have, let's say, r boxes. We have to choose r of them, and the order matters. So what did we do, guys, right now? We had, if we had n, okay, we had to choose n. The answer would have been n factorial. Okay. But do you guys agree that because this value right here is smaller than n, we stopped? Basically, from this 5 into 4 into 3 into 2 into 1. Okay. Since n was equal to 5 and r was equal to 3, we only wanted the first three elements of n factorial. So can we say that this 5 into 4 into 3 into 2 into 1 can be divided by 2 into 1 so that this and this gets cancelled out and our remaining thing is this? Yes or no? And this right here is NPR, and the formula of that is nothing but n factorial divided by n minus r factorial, because we want to remove the last n minus r elements from n factorial. Is this much clear for everyone? Now is it clear where this NPR formula comes from? Tell me, guys. Yes? Okay. If this much is clear for everyone, guys, I'll get to your question back, to your question in a bit, Atharv. Okay, let me just complete this bit and we'll get to your question. After this, guys, if you now understand what permutations are, now let's move on to combinations. Okay, what are combinations, guys? Combinations, okay, let me just write it down. Combinations, okay, is when order doesn't matter. Okay, order doesn't matter. All right. What this is trying to tell us is that if you choose 1 comma 2 comma 5, or you choose 2 comma 1 comma 5, or you choose 5 comma 2 comma 1, all of these are considered as the same choice. Because the set of elements is the same, the choice that we have made is the same. So here, order doesn't matter. The only thing matters is that the numbers that are chosen. Is this much clear for everyone? Yes? Okay. So guys, now I have the same question for you. All right. You have 5 elements. Okay. And you have to choose. Okay. You have to choose 3 elements from this. All right. How many ways are there to choose 3 elements? The numbers you have are 1, 2, 3, 4, 5. Okay. And you have to choose 3 elements from it. How many different ways are there to do this? The only difference here is that, guys, order doesn't matter. Order doesn't matter. All right. Okay. So let me see what you guys are able to come up with. So some people are saying 2 raised to 3. Some people are. So think about it. Yeah, the answer. Yeah, of course, it's 5C3. But how do you actually come up with it? Like, what's the mathematical proof that 5C3 is the answer? We're trying to derive 5C3. Okay, Codeman. Okay. For people who are saying that it's 5 into 4 into 3, all right, 5 into 4 into 3. The fundamental issue with this is here you have two choices, first you can select 1, then 2, and then 3. Similarly, you can select 3 and then 2 and then 1. This won't work, okay, because these two are the same choices. All right, exactly. So, guys, let's actually look on what the answer is. All right, let's not waste further time. You guys are very right. On the first index for the first selection, you have 5 choices. All right. Then, guys, for the second choice, you have 4 choices and then you have 3 choices. But as I said, if you choose 1, 2, 3, let's say one set is 1, 2, 3, it is going to get counted as 2, 1, 3. It is going to get counted as 1, 3, 2. It is going to get counted as 2, 3, 1. It is going to get counted as uh, 3, 1, 2, and it is going to get counted as 3, 2, 1. Okay, these are all the possible ways where the tuple 1, 2, 3 is going to get counted. Can you guys tell me how many ways did 1, 2, 3 occur in my counting? Exactly. How many times did 1, 2, 3 occur in my counting? Didn't 1, 2, 3 occur 3 factorial times in my counting? Because this 1, 2, 3 can be permuted around itself 3 factorial times. Basically, if you want to see the number of orderings of this particular pair, it's just the number of permutations of size 3, which is 3 factorial. So each tuple, basically 1, 2, 3, 1, 2, 5, 1, 4, 5, all of these are being counted 3 factorial times. So what we can do is we can divide this entire thing by 3 factorial, and we can say that this is nothing but NCR. Yes or no, guys? Tell me, isn't this fascinating? Like, it's the same thing. You make choices and then you divide the things that you overcounted. Each tuple is being overcounted r factorial times. So we can say that NCR, okay, NCR is nothing but n factorial divided by n minus r factorial. This is this particular thing into 1 upon r factorial. Exactly. And this is the formula of NCR. We just derived the formula of NCR intuitively. Priyansh is in the chat. So if you guys don't know, Priyansh is founder of TLE and has been running TLE since quite a long time. I also joined in as a student quite like in TLE 3. So it has been quite some journey. So hi Priyansh. Hope uh, it's fun. With that being said, I hope you guys were able to understand how the formula of NCR came up. Do put a yes in the chat if you did understand, or if you have any doubts, feel free to let me know if you have any doubts. All right. I'll wait for a couple of minutes, and if that much is clear for every one of y'all, like I don't think if you guys attend today's session, you won't forget this formula ever, because we don't learn it as a formula. We learn it as exactly. We learn it as a way of thinking. Vineet says, "How did 1 upon r factorial come?" Vineet, do you notice that we divided this entire thing by 3 factorial? Yes or no? Now, 3 factorial, what is 3 factorial? 3 factorial is the number of elements we have here. And if you notice, 3 was the number of elements we chose. So in NCR, this right here is R. So that is why we divided by R factorial. Is it now clear, Vinny? All right. If this is now clear, guys, let's move on to the section. So as you guys see that NCK can be represented as n factorial divided by k factorial divided by n minus k factorial. Okay. Vignesh says, try explain it using an example like 1, 2, 3. Where, okay, definitely, Vignesh. Let's say you had three elements. All right. N is equal to 3 here. And R is equal to 2. Okay. Basically, you have to choose two elements and you have three elements right now. The choices that you can make are 1, comma 2, 1, comma 3. You can make 2, comma 3. So basically, there are three choices that you can make. But if you look at the number of combinations, the way we thought it, it's just 3 into 2. But the issue with this is you can have 1, comma 2, 1, comma 3, 2, comma 1, 2, comma 3, and 3, comma 2, and 3, comma 1. As you can see, 1, comma 3 and 3, comma 1 got double counted. All right. 2, comma 1 and 1, comma 2 also got double counted, and these two also got double counted. Basically, every tuple is being permuted by itself. All right. So we have 6 choices, and for each choice, it is being counted 2 factorial times the number of permutations of itself. So if we divide this by 2 factorial or 2, we'll get our answer, which is 3, which is indeed the number of choices we can make. Is it now clear, Vignesh? All right. If that is indeed clear, let's move on further. Like this is the formula, and mathematically, this is how we write down NCR. Okay. You can write down NCR like this, but on Code Forces or any mathematical forums, you'll look at NCR being denoted like this. And this is the same, like it's the same symbol. Okay, it denotes the same thing. It's NCR. All right. If that much is done, now there is a new problem. Okay. The problem is you are given Q queries where Q is smaller than equal to 10 raised to 5. Okay. After this, for each query, you have to print, you are given an N and an R where R is smaller than equal to N and both N and R are smaller than equal to 10 raised to 5. Your task is for every query, print N CR modulo some mod, let's say 10 raised to 9 plus 7. Okay. This is what you have to calculate. So take your time and let me know how you can accomplish this. This is again a very important thing to learn. So if you know about NCR, but you don't know how to solve this problem, it's a great time to start paying attention so that you'll get to learn how you can do this particular thing where you have to calculate a lot of NCR based things, but you can't actually go about brute forcing the entire thing. So how do you go about doing this? Okay. So Bharat is saying that run a for loop from N to R. But the issue with that, Bharat, is that our worst case, you are running a for loop O of N times. Okay. Ram says, can you repeat the question? Definitely, Ram. So you are given Q queries. Let's say Q is, let's say 5. And on each query, you are given an N and an R. Let's say 5, 2, 10, 3, 7, 4, 3, 2, and 6 and 1. For each query, you have to print the value of 5C2 modulo mod, and mod in this question is 10 raised to 9 plus 7. Okay, and here both are smaller than equal to 10 raised to 5. Okay, definitely, Bharat. It is better, but the time complexity would remain the same. All right. So, guys, how do you go about solving this problem? Let's have a look. The first thing that you can see in this problem is that n comma r is smaller than equal to 10 raised to 5. Yes or no, guys? Tell me. Since n comma r is smaller than equal to 10 raised to 5, the thing what we can do is we want to know some factorials. Okay, we want to know n factorial, we want to know k factorial, and we want to know n minus k factorial. Can we, okay, before processing all the queries, like what we can do is, okay, we can for each query run a O of n for loop, but that is of course inefficient. It would result in a TLE. Do you agree, since n comma r is smaller than equal to 10 raised to 5, we would need factorials, okay, only up to 10 raised to 5. So what we can basically do is pre-compute, okay, pre-compute all factorial values modulo mod up till 10 raised to 5. Yes or no? Yes. And guys, for calculating each factorial, do you need to run a for loop? Like to calculate, let's say we wanted to calculate, we are calculating factorial from I is equal to 1. Let me change the color back to purple. I is equal to 1 to I is equal to 10 raised to 5. Okay. If I want to calculate factorial of I, can we use the factorial of I minus 1? Yes or no, guys? I factorial can be said to be, or n factorial can be said to be n into n minus 1 factorial. Yes or no? It's just n minus 1 into n minus 2 up till 1 multiplied by n. So can we say factorial of I is nothing but factorial of I minus 1 into I, the whole modulo mod? Yes or no, guys? Can we do this? So in O of capital N time, where n is 1e5, we are able to pre-compute all factorials from 1 to 10 raised to 5. Is this much clear for everyone? And we can set factorial of 0 to be 1. Okay. Is this much clear? Do put a yes in the chat if it is indeed clear. If you have doubts, definitely let me know what doubt you have. All right. I'll just wait for a couple of minutes so that everyone is on track, and then we can move on to the next phase. How is that O of n? Bharat, we are calculating 10 raised to 5 factorials while iterating 10 raised to 5 times. So, although we are iterating from 1 to 10 raised to 5, we are calculating all values from 1 to 10 raised to 5. So that is why the time complexity is capital O of n. This n and this n are different. All right. It's just like prefix sum. All right. If this much is clear for everyone, guys, let's move on to the next part. All right. Exactly. This you can say that this is DP, but I don't want to complicate it. You can just say that you are pre-computing it. Okay. It's just a fancy name. Now, if this much is clear, guys, when you want to calculate NCR, all right, you have n factorial modulo mod with you. Okay. You have n minus r factorial modulo mod with you. Okay. And we have r factorial modulo mod with us. Okay. Let's say this is x, this is y, and this is z. Okay. Keep in mind, this is very important that we have calculated them modulo mod. We have not calculated their actual values. We have calculated their values modulo mod. Can I just print x divided by y into z? Can I just do this? Is this correct? If would this be correct? Like if I just print x divided by y into z? No. And why would that not be correct, guys? Tell me. No, that is fine. Let's say it was divided by into mod. Okay. Would this be correct now? Okay. And guys, this is not correct. Okay. This is not at all correct. Why is this not correct? Let me give you a very quick example on why this is not correct. Okay. Let's assume you wanted to print 4 divided by 2 modulo 3. Okay. This is what you wanted to calculate. Now, guys, we calculated 4 modulo 3, which is 1. You calculated 2 modulo 3, which is 2. Now, can we say 4 divided by 2 is same as 1 divided by 2? No, it is not. Because here our answer should have been 2 and here we are getting 0.5. Is that correct? That is not correct. Yes or no, guys? You can see that we are not getting the same answer. So do you agree we need to have the same answer? So guys, here is when another concept comes in. Usually in TLE, we teach this in a separate class, but since you guys don't have access to that class right now, if you would like to learn in detail, definitely you can join us at TLE, but let me just give you a brief. Okay. Whenever you want to calculate A divided by B, okay guys, modulo some mod, we cannot really do this as it is. Okay, this is the difference. Subtraction you can do it as it is, addition you can do it as it is, multiplication you can do as it is, division you cannot do as it is. For that we need Fermat's little theorem. Okay, and let me get into that. Okay, the first thing I want to ask you all guys, can we say, okay, let me move on to the next page. Can we say that A divided by B is same as A into 1 upon B? Yes or no, guys? Is it the same? It is the same, right? It is just separating the numerator and denominator. Yes. So, guys, can we say that this is equal to A into B inverse? Yes or no? B raised to minus 1. So guys, this right here, this inverse in modular arithmetic we can calculate, and this is known as modular inverse. All right. Basically calculating 1 upon b for any b. Now, how do we go about doing this? We do this by exploiting Fermat's little theorem. What does Fermat's little theorem say, guys? A raised to p raised minus 1, okay, the whole modulo mod is equal to 1 is the same as 1 modulo mod. Okay, guys? This is known as Fermat's little theorem. I won't be getting into proving this right now, but what does Fermat's little theorem say? And this is not p, guys. This is mod minus 1. Okay. A raised to mod minus 1, the whole modulo mod is the same as 1 modulo mod. Is this much clear for everyone? This is the only part of the video where I'm asking you to accept something as it is. Okay, because of time constraints, not because I cannot really go into depth of it, but is this much clear for everyone? This is what Fermat's little theorem says. Okay. Now, guys, we know that we have this equation. Okay. What do we want? We want to calculate 1 upon a. Yes or no? Tell me. Since we want to calculate 1 upon a, can we divide both sides by a? Basically, a raised to mod minus 1 modulo mod divided by a is same as 1 upon a modulo mod. Now, guys, a raised to mod minus 1 divided by mod is same as a raised to mod minus 2. Yes or no? Tell me. So, can we say that 1 upon a modulo mod is same as a raised to mod minus 2? Yes or no? Modulo mod. Now, guys, my question to you is, we came across this, that a inverse modulo mod is same as a raised to mod minus 2 the whole modulo mod. My question to y'all is, this right here is like 10 raised to 9 plus 7 minus 2. How are you going to calculate a raised to something very fast? How are you going to calculate a raised to something, and this something is large, okay, something large? You need to compute this very fast. How do you do this? Exactly. We use binary exponentiation to solve this problem. Exactly. Exponentiation to solve this particular problem. So, guys, we can calculate a raised to something very fast using binary exponentiation. So, if you have this much in mind, now going back, okay, guys, we have x, y, and z. And do you guys agree that we want these values to be on denominator side? So can we say that NCR is equal to x into y raised to mod minus 2, the whole modulo mod, okay, into z raised to mod minus 2, the whole modulo mod, the whole modulo mod. Can we say that NCR is equal to this? Yes or no, guys? Instead of dividing, can we say that the multiplying x with their inverse will give us n factorial divided by n minus r factorial divided by r factorial? Yes or no, guys? Okay. Now, using this trick, we will be able to solve this pretty fast. How much time does it take to compute this? We have this in O of 1, this in O of 1, this in O of 1. Raising anything a raised to b takes O of log mod time, log 2 of mod time. Okay. So in log of 10 raised to 7, which is around 30 iterations, you are able to get NCR for each hour. But the question here is, guys, we know that we want to compute the inverse of factorials. So the thing I want to ask you all is, we are storing a vector for factorials. Can we store one more vector for inverse factorial? Yes or no? If we are able to pre-compute this, then we can just answer each query in O of 1 time. Right now it is fine. It is O of log 2 mod time. You will get an AC. But in some problems, you want to optimize even more. So my question to you is, if we are able to pre-compute an inverse factorial vector, do you agree these two parts we would be able to get in O of 1 time? So we would be able to answer each query in O of 1 time. Yes or no? Tell me, guys. Yes? Is this much clear, guys? Tell me. All right. If this much is indeed clear, how do you go about computing this inverse factorial thing efficiently? Is something which I want to ask you. All right. And the answer is actually very simple, guys. Can we say, okay, I want to ask you all something. Can we say 1 upon I factorial is nothing but 1 upon I plus 1 factorial multiplied by I plus 1? Yes or no? Can we say this is true? From I plus 1 factorial, if we multiply it by or I plus 1, that I plus 1 goes away. So can we say 1 upon I factorial is equal to 1 upon I plus 1 factorial into I plus 1? Now, if this much is true, guys, we can compute inverse factorial, okay, inverse factorial of 1 5, okay, which is nothing but factorial of 1 5 raised to mod minus 2. Okay, this can be calculated using binary exponentiation. After this, we can just say that inverse factorial of 1 5 minus 1 is equal to inverse factorial of 1 5 into 1 5 modulo mod. Or what I'm trying to say is, you run a for loop from I is equal to n to I is equal to 0. Okay. And we can say that inverse factorial of I is equal to inverse factorial of I plus 1 into I plus 1, the whole modulo mod. Yes or no, guys? Tell me. Is this much clear for everyone? And we can have this from n minus 1. Yes. Do take your time and let me know if this much is clear for everyone. If this much is indeed clear, I'll show you the implementation of the same. And after that, we can move on to more exciting things around NCR. Okay, guys. Definitely, Mohammed. I'll definitely look into it after the session. Okay. Now, guys, Yeah, there are a lot of problems on code forces. Guys, let me show you the implementation. Okay. If you look at the implementation, what are we doing? We have the factorial vector. We have the inverse factorial vector. Okay. Ignore this. Ignore this line. Okay. Factorial of I is equal to factorial of I minus 1 into I modulo mod. There is just a function for modular multiplication which does the same thing. It's just returning factorial of I minus 1 into I modulo mod. This is exactly what it is doing. Okay, guys. Now, after this, you can see that inverse factorial of n is said to be factorial of n raised to mod minus 2. Okay, this is done using binary exponentiation. This function basically calls binary exponentiation. And after this, you can see that we are just iterating from n minus 1 to 0, and we are saying that inverse factorial of I is nothing but inverse factorial of I plus 1 into I plus 1 modulo mod. Okay. Is the implementation clear, guys? And then let's say we have to print 8C6. So we are given N, we are given R, and we are given also the mod through which we have to answer. So it is nothing but factorial of N into inverse factorial of R into inverse factorial of N minus R, the whole modulo mod. So you multiply these two, you mod with your mod, and after that you mod this entire thing with this, and you return the answer. Is this much clear for everyone, guys? Tell me. Isn't this crazy? With O of capital N pre-computation, you are able to answer each query in O of 1 time. Bharat says, I did not get binary exponentiation time. What we are trying to do here is that if you didn't get binary exponentiation, I'll suggest some resources. Bharat, binary exponentiation is a topic in itself, like to calculate a raised to b modulo mod. Then what do we do? CS Codeman says, which level in TLE 12.0 will you be teaching? I'll be dividing myself in TLE level 3 and level 4. I love teaching advanced algorithms. So if that is something you're interested in, you can definitely check out TLE level 3, level 4. If you look at the topics of level 3, level 4, if they see that they are too advanced for you, you can check out level 1 and level 2, and they are also taught by very amazing tutors, which is Harsh and Viraj. Yeah. Okay. So if this much is clear, guys, I think we have covered a very important concept in NCR, which is basically computing NCR in O of 1 time. Now that you know this trick, you will be able to solve a lot of problems. Okay. Now you have a template. And talking about template, since you guys are over here, I have made like this is Jiangli's template. Okay. You don't need to do anything. Everything is written. So you just need to copy this entire thing. I'll share the link also. Let me share the code right now in the chat. So if you have all of these things, you can just call your math int and the maximum value for n. And after that, if you just print out m dot choose 10c2, basically this is n, this is r, this will just print. So you can see that here we have 10, here we have 2, and here 45 got printed. So I'll just share this code in the chat. So since you were able to, I'm sharing up till, I'm sharing the entire template in the chat. You can definitely go through this. Okay. Okay, I think it has come up as multiple comments, but I'll share a paste bin link. Okay. Post the live session, you'll be able to see a paste bin link through me. Okay. So it's very simple. You have your math int, so it gets resized up to n, and then this entire thing is being calculated. And after this thing is being calculated, you can see that you have your exponentiation, and in NCR you just have factorial of n, which is getting multiplied by inverse factorial of n minus k, and which is getting multiplied by inverse factorial of k. So that is just a simple template. Since you guys were so enthusiastic, I'll just share this template with you guys, so you don't have to implement this on your own in the contest. You can just use this template and get queries done in off on time. Is that okay? Okay, it does the same thing that I taught. It's just you can just save it as a snippet. With that being said, let's move on to the next concept. Okay, the thing I want to show you all today is, guys, some observations. Okay, Ram, you can look at level 3. I would suggest yes, if we pre-compute the values, we can answer each query in less time. For 1250 rating, you can take up level 3. If level 3 seems very advanced, you can take up level 2 as well. With that being said, let's look at some observations. Okay, guys. And I would be teaching you all some things. The thing is, NCR is equal to NC n minus R. Okay. And how do you go about choosing this? The first thing is, this is the same as choosing R items is same as discarding R items. Okay. And how do you go about proving this? Like, proving this is very simple. The thing is that, what is NCR, guys? It's n factorial into R factorial into n minus R factorial. Now, instead of R factorial, let's have n minus R. So it becomes n factorial into n minus R factorial into n minus R factorial. Okay. And now this n gets cancelled out. This minus becomes plus. So it becomes n factorial into n minus R factorial into R factorial. Can you see that these two formulae are the same? Yes or no? So what I mean to say this, guys, is choosing R items is the same as discarding n minus R items. Basically, the intuition behind this is, if you have 5 items, let's say 1, 2, 3, 4, 5, okay, and you are told to choose 3 items, okay, let's say you choose 1, 3, and 5. Does this also mean that you discarded 2 and 4? This choice is the same thing. Not choosing 2 and 4, not choosing n minus R items is the same as choosing R items. Is this clear with everyone? It is live, Nikhil. Why do you think it is recorded? It is live. Okay, great. Now, if this much is clear, guys, let's move on to the next observation. Okay. And the observation is very simple. Let's say you wanted to calculate NCR. Okay. And this is where dynamic programming comes in. Like, it's not dynamic programming, it's just a recursion. NCR is, you have to choose from n elements, R elements, right? So guys, let me write down 1, 2, 3, 4, so on and so forth up till n minus 1 and n. Okay. Assume that, guys, you are over here. All right. And after that, you have to choose R things. All right. Tell me, guys, now do you have two choices over here? Either you can pick n, otherwise you can not pick n. Yes or no? If you pick n, we can say that from these remaining things, okay, oops, from these remaining things, if we pick, we have to choose r minus 1 elements. From n minus 1, we have to choose r minus 1 elements. But if we do not pick n, okay, Raghav says, I have watched level 3, but my rating is 1200. Should I choose level 4 or wait for level 4 in 13.0? If you have understood everything in level 3, Raghav, I would recommend that you can feel free to choose level 4. Okay. Otherwise, what you can do is you can uh, take up, like, even if you don't want to look at the content right now, you still have around 3 to 4 months extra. You can use the doubt solving forum more or less. At TLE, we have a very cool feature. Basically, we have a set of very high rated people. And whenever you have a doubt or whenever your code is like you're stuck in your code, what you can do is for a long time, you can just ping on Discord that, hey, my code is stuck, and someone will definitely pick it up. And in 5 to 10 minutes or something like that, will let you know that, okay, this is the exact problem in your code, and we'll explain the entire thing to you on Meet or via text. So you can definitely use that, but it's up to you. Like, you need to analyze what you need to improve on and take a decision likewise. Like, if you feel that you need more practice, you can definitely practice more this time and take up uh, level 4 next time. Otherwise, you can take up level 4 this time and learn and practice simultaneously. Okay, definitely we can have profile review sessions at the end. Okay, I'll definitely take up these problems at the end, guys. I'll take up one last question, and then at the end we'll take up more questions. I have a lead code rating of 1780 and solved 1700. I haven't done code forces and CP before. Uh, if you are weak at math, you can take up level 3. Level 3 focuses on math. Level 4 focuses, like, if you go to the website, guys, here, you can look at what topics are being taught. Like, if you look at level 4, you can see the entire thing, what is being taught. Like, first, we'll have a lot of dynamic programming, like a lot. After that, we'll look at segment trees and lazy propagation. Then we'll look at sparse tables. Then we'll look at trees, dynamic programming on trees, binary lifting, lowest common ancestor, and all of that. Then we'll look at Euler tour and subtree queries, DP on trees. We'll look at graphs, shortest path, minimum spanning trees, directed graphs. This this directed graphs has not been explored further, like written further, but we have strongly connected components, condensing the strongly connected components, and all of those things. So a lot of things in level 4. But if you look at level 3, let me just go to level 3. Level 3 is more focused towards number theory, combinatorics, probability expectation, greedy algorithms, tries, and string hashing, and all of those things. Okay. So definitely all of that. With that being said, let's get back to the session. We'll get to more questions later. Okay. Our focus today is to have as much content for you guys. I don't have any idea of TP. Will it be? It will be beginner friendly, Rag. Okay. If you want to have a look at idea how dynamic programming is, you can have a look at the entire dynamic programming playlist by Priyansh. I think that will give you a good gist of dynamic programming. Like, the first 16 problems of CSES were taken. So you can definitely have a look at that playlist. I think uh, you can just put up Priyansh Garwal dynamic programming, and the entire playlist should come up for free on YouTube. Okay. Like, there are multiple resources. Zero Enemy says Striver DP, anything that works for you. Okay. Now, getting back to our main topic, guys. Let's focus for 5 to 10 minutes, and then we'll get to more things about the course. Guys, we have to, from n things, you have to choose R. Okay. Let's say we are on the nth item. Okay. Do you agree? You have two things that you can do. You can either pick the nth item, or you can not pick, okay, not pick the nth item. Yes or no? If you do not pick the nth item from the remaining n minus 1 items, you have to choose r items because you haven't picked anything. You haven't picked the n item. Oh, sorry. You have to choose an r minus 1 because if you do pick up the nth item, you have chosen one item. Now you have to choose r minus 1 items. So from the remaining n minus 1 items, you have to choose r minus 1 items. But if from the nth item you do not pick it, you say that, okay, I don't want n. From the remaining n minus 1 items, you still have to choose r items. Yes or no, guys? Is this much clear? We have n items. Let's say you're on the nth item or the first item, whatever. You choose whether you want it in your choice or you don't want it. If you do want it, you can say that from the remaining n minus 1 items, I have already chosen one item. So now I have to choose r minus 1 items. But if you do not choose it, you from the remaining n minus 1 item, now you have to choose r items. Is this pick not pick idea clear? Yes or no? Tell me, guys. Clear? Okay. So guys, can we say that NCR is equal to nothing but sum of these two, which is if you pick the nth item, what happens? Plus, if you do not pick the nth item, sorry, this is r minus 1, what happens? Can we say that NCR is n minus 1 CR minus 1 plus n minus 1 CR? Yes or no, guys? Tell me. Yes or no? Yes? If this much is clear, guys, let me write this down for you. NCR is equal to n minus 1 CR minus 1 plus n minus 1 CR. Can you guys tell me what is this formula? Trust me, when you will know, you will enjoy every single bit of it. What is this formula? Guys, this right here is the formula that we see in Pascal's triangle. If you draw Pascal's triangle on the previous row or the n minus 1th row, if you have two elements, the sum of those two elements forms NCR. And that is when this formula comes up. NCR is nothing but n minus 1 CR minus 1 plus n minus 1 CR. And this is exactly what Pascal's triangle is. Isn't this beautiful, guys? Tell me. Pascal's triangle, for people who don't know, it's 1, 1, 1, and then uh, 1, 2, 1, and so on and so forth, right? The sum of these two, basically 3C2. Okay, great. If this much is clear for everyone, guys, we now have the most, okay, the most important thing. Like, let's move on to problem solving. the most interesting thing today, that is, we'll be looking at 4 problems, and we'll be looking at each problem in detail. Okay, creating strings, kth string unique paths, and arranging n items. All right, now guys, the first thing is creating strings. I'll give you the problem link. All right, it's creating strings 2 on CSES. Let me just share the link. Oops, 1 second. Copy. Great. Raghav says, do you recommend solving 10 problems a day? It depends upon person to person. Like for some, like solve as much as you can. I wouldn't say solving 10 problems a day will give you success. It's more about, are you challenging yourself every single day with the topics, with the problems that you're solving? Are you getting to learn? Is your problem solving improving? Ask these questions to yourself. Don't make your goal that you want to blindly solve 10 problems or 5 problems or 2 problems or even 1 problem. Every single problem you solve, you should be able to gain something out of it. You should learn. Like at the end of the problem, you are like, oh, this is what I learned. If that is not the case, then you're not, that solving that problem had no use. So try to keep your problem practice session more meaningful rather than I just want to get this much done every single day. Okay, let me turn off air condition. Okay, so guys, let me just zoom into this a bit. And the problem says that you are given a string and you want to calculate how many different strings you can make through this. Okay, so for ABAC, you can use this particular string and rearrange it in 20 ways. How do you do that efficiently? So guys, read the problem, take around 5 minutes, 2 3 minutes to think around it. Okay, it's, what's the time right now? It's 9:08, and I'll give you all time till 9:10, and you can definitely look into it. Siddhanshu says, can you review my profile in the meantime? Siddhanshu, I would love to do that, but the thing is, once I start reviewing profiles, a lot more requests are going to come in. So give me like more 30 minutes. In 30 minutes, we'll be covering 4 good problems. After that, we'll take up profile review session, and we'll take up a Q&A session for every one of y'all who wants to know more or has questions about their profile, questions about TLE, everything. Okay. I don't have a laptop. Can I solve lead code problems on my mobile? You definitely can, and that's very nice of you to still want to solve on mobile, not having a laptop. So kudos to you, and I hope you do well, Daya Shankar. Okay, because like if you guys don't know, there have been a lot of competitive programmers who don't have laptop in their first year of college, but they still used to code out in their on their mobile, and it panned out really well for them. Okay, with that being said, let's discuss the problem. Okay, the problem says, guys, that you are given a string. Let's say the string is AAB. Okay, you need to find how many distinct rearrangements are there of this string. So, as someone says in the chat, you can permute the string. So you can find A, B. Okay, you can find A, B, A. You can find B, A, A. Okay, and I think these are the only 3 possibilities of this particular string. But the thing is, guys, that if you just do 3 factorial will give you 6, and that is not the answer. And why is that the case? Because these two A's are considered as different entities, but they are not. They are the same entity. Yes or no, guys? So whenever you have an AAB or a AABC, this what this 3 factorial leads to, it leads to counting A1, A2B and A2, A1B as two different strings where they should have been counted as the same string. Do you guys agree that from this 3 factorial there is some double counting? So if we divide by something, we should be able to avoid this double counting. Now the question is, how do you by yourself? Like if you know the formula, you've learned in 11th, 12th, amazing. But if you don't, how do you come up with this on your own? The thing is, guys, if you have a B fixed and you have a A, do you agree you can have A1 here as well as A2? You can have A2 here as well as A1. Can we say that if you fix the non-A's, the remaining positions that are there, the A's are going to permute within themselves? Since there are two A's right now, there are going to be two factorial strings where A's permute. Yes or no? Like instead of A, let's say we had A, now we have A1, A2, A3. So if we fix a B and let's say these are the positions, you could have had A1, A2, A3. You could have had A3, A2, A1. You could have had A3, A1, A2. So if you fix the B, can we say that the A's are permuting within themselves? Yes or no? So can I say that this is nothing but 3 divided by the number of times A caused the double counting, which is 2 factorial, because there are two A's, and apart from that, into the number of times B caused a double counting. Now B is only one, it doesn't count, doesn't make a double counting. But let's say it was A, B. Now let's say these are the positions for your B and these are the positions for your A. Now your B's can permute here and your A's can permute here as well. So can we say that then that becomes 4 factorial divided by 2 factorial divided by 2 factorial? Yes or no, guys? Tell me. Yes. We basically want to remove the double counting. And that is why we say that, okay, these A's are permuting within themselves. So we just remove how many times they are permuting. For every string, the A's can permute 2 factorial times. So we can say that it's 3 factorial divided by frequency factorial multiplication. If I go back, you can see that if there are n elements, okay, arranging similar elements can be said to be its sum of how many ever elements are there, factorial, divided by the frequency of the first type, the frequency of the second type, so on and so forth into frequency of the last type, factorial. So if we wanted to know the number of permutations or number of distinct anagrams of AABAC, okay, AABAC, can we say this is nothing but 5 factorial divided by 3 factorial into 1 factorial into 1 factorial, which is nothing but 5 into 4, which is 20. And you can see that 20 is our answer. Is this clear for every one of you guys? Tell me. Clear? Amazing. If that much is clear for everyone, let me just show you the implementation of the same. So guys, you can see that you take an input of the string, you calculate factorial inverse factorial, and after that you store the frequency of each character. Your answer is just uh, n factorial, and after that for every frequency you multiply it by inverse factorial of I dot second, and you mod it by p, and in the end you just print the answer. Okay. Dia says, can you explain the mod part in this question? Dia, this particular entire thing, what we have done right here, has been covered earlier. Like if you go some minutes back, you will notice that we covered exactly this thing, calculating NCR modulo M, right? So you calculate factorial, inverse factorial, and then printing NCR can be done in O of one time. So the same trick has been applied over here, where basically we want to calculate n factorial divided by uh, other things. So the other things can be said to be, instead of 1 upon A, we can say it's A inverse. So we have calculated A inverse for every number. And after that, we just print n factorial divided by frequency factorial. Okay, great. Is this much clear for everyone? If this much is clear, now we'll move on to one of my most favorite problems. Okay, so do let me know if this much is clear for all of y'all. Okay, okay. If this much is clear for every one of you guys, now is my favorite moment, the mind blowing moment of this particular session. Okay, you are given a grade. Okay, and this grid has n rows. I will definitely Krishna. Okay, and we have m columns. You are a robot. Okay, consider that you are a robot. You start at cell 1 comma 1, and your task is to reach cell n comma m. Now the only operations you are allowed to do, basically if you're on a cell, you are only allowed to go either towards the right or towards the bottom. Your task is to find the number of paths. Okay, the number of paths from 1 comma 1 to n comma m. And I'm not looking for the dynamic programming solution. I'm looking for a linear math solution. For example, this is one possible path. Similarly, this is one possible path. Similarly, this right here is one possible path. And similarly, this right here is one possible path. Okay. So these are the possible paths. Your task is to calculate this thing. So take 5 minutes. I'll be back. Okay. Just give me 5 minutes, guys. I'll be back in just a second. Okay. So I am back. I just have some cold. So I've gone to clean it. But that being said, how do you go about solving this? Take your time. It's 9:19. I'll give you all around a minute or two more, and let's see how you go about doing this. It's a very beautiful problem. It's a very classical and beautiful problem. Okay. It's a very pretty problem, and I think it's very important. So if everything else was easy, throughout this session. I am sure that this is not going to be easy. So let's have a look. Why? Like, first of all, that is not like it's a bit off home, but we would like to know why. That is the more important part. Like at TLE, whenever we teach, our goal is to uh, satisfy the curiosity behind why things are the way they are. And I think in competitive programming also, if you start questioning things like why is it this way, why is it of this sort, and try to understand why things are the way they are, it will help you on the long run. It will help you on thinking better. It will help you do much better in competitive programming. Okay. Hello, sir. My rating is 1200. Should I shift to Code Chef? Yes, you should shift to Code Forces, Arpit. Practicing on Code Forces is much better as compared to practicing on Code Chef, because Code Forces problems are of higher quality than Code Chef. So if you keep practicing on Code Forces, you will get better. Not to mention the admin of Code Forces, which is Dominator 069. He himself practices on Code Forces, so you will know. Okay. So guys, it depends on which level, Krishna. So you can definitely look into that. Guys, let's start with the solution. Okay. I can't hold it within me. Okay. Guys, I'll give you a walkthrough today later. Okay. Arpit? Let's say n is equal to 3. Okay. And m is equal to 4. All right. Now, guys, do you agree that when you are a robot over here, no matter which path you take, let's say you took this path, or let's say you took this path, do you agree you have to take 1, 2, 3 right moves? You have to take 3 rights and you have to take 2 downs. Yes or no? Tell me. No matter what path you take, that path is going to consist of 3 rights and 2 downs. Correct? Basically, if you want to formulate it uh, mathematically, it is going to consist of n minus 1 right moves, and it is going to consist of n minus 1 down moves, no matter which path you take. Yes or no? Tell me, guys. Yes or no? Put a yes in the chat if it is indeed clear. Okay. So, guys, can we say that our path, if you jot it down as an array, it is just n minus 1 right move, n minus 1 downs, and m minus 1 rights. We just have to place these characters in our array. And the number of characters, or the number of arrays we can create, is the number of paths we can have. Because no matter, like, if you look at here, like 3 rights, 1 down, if you go right, right, down, down, right, it creates one path. But similarly, if you do right, down, right, down, right, this creates another path. So you know how many rights you have and you know how many downs you have. You just have to find the number of ways to create this particular array. Yes or no? And this is the exact problem that we solved, guys. The answer to that is nothing but n minus 1 plus m minus 1 factorial divided by n minus 1 factorial into m minus 1 factorial. So we place n minus 1 and m minus 1 in different. Yes, you have n minus 1 down moves and you have r m minus 1 right moves. You just have to find in how many ways can you, how many sequences can you create. So basically, you have n plus m minus 2 positions and you just have to find how many different arrays you can create such that that array has n minus 1 down moves and m minus 1 right moves. Now we just had a look at how to find the number of arrays. That is nothing but n factorial, which is n minus 1 plus m minus 1, which is n plus m minus 2, divided by, you have down how many times? N minus 1 times. So you don't want them to permute within themselves. So you divide it by n minus 1 factorial. And you have how many rights do you have? You have m minus 1 rights. So you don't want them to permute within themselves. So you divide by m minus 1 factorial. So the number of ways of moves, if you change the problem, you know that the number of right moves and the number of down moves are fixed. So the problem changes to how many arrays you can create such that you have m minus 1 right moves and n minus 1 down moves. And that we just had a look at. It's the same as the previous problem. You have n and you know the frequency of d and frequency of r. So that is just n plus m minus 2 factorial divided by n minus 1 factorial divided by m minus 1 factorial. Is this much clear for every single one of you guys? Isn't this beautiful? Isn't math beautiful? We decompose something completely different. Number of paths to number of ways of creating an array where the constraints are set. And we just had a look at it in the last problem. And that boils down to this formula. Yes or no, guys? Clear? Okay. If this much is clear for you all guys, the time complexity isn't n into m. The time complexity is n plus m, because if you look at it, what you want to calculate? You want to calculate n plus m minus 2 factorial, okay, divided by n minus 1 factorial into m minus 1 factorial. So you can calculate this in big O of n plus m. You can calculate this in big O of n, and you can calculate this in big O of m time. So the time complexity to calculate this becomes big O of n plus m. Okay. There is a link on lead code where you can go and solve it today. Like, I won't give you the implementation, that is your task. So you can go to lead code. It's called lead code / problem / unique paths. Although this is done using dynamic programming, your task today is to solve the same thing using combinatorics. I've given you the solution. You just have to go here, implement it, and get it submitted. Okay, guys? Okay. If that much is clear, let's move on to the last problem of today. Okay. We'll be done right now, Atharva. Okay. The question is that, yes, last problem, and then we go to profile review and all those questions. Okay. The question is, you are given n items. Okay. Let's say 1, 2, 3, 4, 5. All right. You have to choose r items. Okay. But you are also given a set of k items. Okay. Let's say 1, 3. Okay. Let's say k is equal to 2 here. The question is that You have to choose R items. Okay. And the constraint on it is that if you choose one, which is part of the set that was given to you, K was 2 and one of its element was 1. If you choose one, you have to choose all the other elements of that set. So here the set is 1 and 3. So if you choose one, you have to choose 3. And if you don't choose any of them, that is fine. But if you choose 3, you have to choose one similarly. How many ways are there such that from the given n items, where these two are basically a group, you have to choose R items. So basically, you can say that these two are a group. If any one of them exists, then both of them have to exist. So let's say R is 3 here. So the possible combinations where you do select 1 are 1, 3, 2, 1, 3, 4, 1, 3, 5. And the cases where you don't select 1 and 3 are obvious. It's just 2, 4, and 5. So these are the possible ways where you can indeed do it. So the question is how do you go about solving this? You are given n, you are given r, and you are given k. K is, let's say, the set of elements, and you have to print how many ways are there to select r elements, such that if you select one of the elements in the set, you have to select all of them. If you don't select any of them, that is absolutely fine. So think around it for 5 minutes. I'll just be back in a second. Okay. All right. In the meantime, guys, I would like you all to tell you all again that TLE 12.0 is live. Like, let me just get that done, and then we can take permutation of each number. You can do that, but this is a harder problem. Okay, think around it. I think I'll explain how to go about it because we've already have a 1.5 hour session. Okay, Aditya, just give me 1 minute. I'll take your question. I'll definitely take up a lot of questions. Just give me a second. Okay. So, guys, the question says that we are given n, r, and k. Okay. And we are also given the elements here. We have to find the number of ways to do so. How do you go about solving these problems? Now, guys, the thing is, I think this will help you in your competitive programming journey also. The idea is that you solve it by casework. Okay. Now, guys, do you agree there are two scenarios? Okay. What are the two scenarios? You pick the set. Okay. Because even if you select one element, you have to pick the entire element. You pick the set. Otherwise, you don't pick the set. Yes or no? Now, guys, if you pick the set, do you agree that you have chosen k elements already? So, from the remaining n minus k elements, you have to choose r minus k elements. And similarly, if you don't pick any of those elements, from the remaining n minus k elements, you have to choose r elements. Yes or no? If you do pick up that entire set, you have n minus k elements remaining, and from those n minus k elements remaining, you have to pick r minus k elements because we have already chosen those k elements. You don't pick them. From the remaining n minus k elements, you have to choose r elements, and that is more or less the formula. You either pick the entire set or you do not pick the entire set. So the answer is just n minus k c r minus k plus n minus k c r, and that is more or less the solution to this particular problem. Is this much clear for every one of y'all? Okay, this was a bit on the harder side. The idea is that you use casework, you divide it into two parts, basically pick and not pick, and you solve for each part uh, by its own. These are the kind of problems that are getting more and more famous these days because AI is not able to solve these problems. So, whenever you are given such problems, look at what choices you have, what cases you have. So, either this entire set is going to get picked, otherwise, it is not going to get picked. If you do pick it, the number of ways of selecting rest is n minus k, cr minus k, otherwise, n minus k, cr. That is more or less it for today's session. I hope you enjoyed. If you did enjoy this, do drop a like and let me know how did you like today's session. Was there anything that I could have improved? And we'll definitely take up questions now. Your favorite time. Thanks a lot for joining in. For people who did come up for learning combinatorics, that is more or less it. The last thing that I want to cover up is that our courses are live. So we'll be teaching similarly with our videos on, with screen recording on in our courses. So you can definitely look up at TLE Eliminators / courses and have a look at what course you want to take up. If you want to take up, otherwise, we'll definitely be uploading uh, free resources on YouTube every now and then. With that being said, I think now we can take up profile review sessions and what to do. Let's take up Aditya's question. I am in my third year of engineering. What's okay? I'm in your third year of engineering. What's your advice? I did almost 250 of driver sheet and I am thinking level 3 will it be useful for upcoming placements and stuff. Okay. So Aditya, it depends on what you want to learn. If you want to, if your math is weak, if your two pointers, binary search on answer, interactive problems, string hashing, and all of those things are weak, definitely take up level 3. Otherwise, if your dynamic programming is weak, if your advanced algorithms like graph, trees, segment trees, dynamic programming is weak, then take up level 4. Also, this is mostly curated towards competitive programming, so we would be going in more depth than your normal lead code, DSA, and all these things. So it is going to be more detailed and it's going to be more advanced. So will it help you? It will help you clear your OAs if in terms of placements. And if you do end up doing well, like if you do put your heart and soul into it, interviews shouldn't be that hard. But the main goal is to make you a better problem solver, make you a better competitive programmer, because once you're all of this, everything else is just a byproduct. Okay, getting into companies, getting into whatever, getting into a good college, right? All of these are just byproducts. uh yes, what did you ask, Atharva? Can you just put it in the chat? It's lost, so just put it again. I'll definitely take up your question. Bharat says, I learned combinatorics finally because of you. Thanks a lot. Thanks a lot, Bharat, for your kind words. I hope it did help you. Okay. Bharat says, yesterday code forces question A. I came up with binary search on answer approach. Is it correct? I haven't looked at the problems. I was ill, so I didn't give the contest yesterday, but I'll definitely look into it and let you know. Okay. Uh, Atharva, do put your question in the chat, and Sitanshu, do put your Code Forces profile link in the chat as well. Uh, Ram says, I solved CSES and educational DP contest like good in DP, but my rating is binary search and two pointers greedy. Okay, so Ram is saying that binary search and answer, two pointers, greedy are weak. So it depends on what you want to do. If you want to join level 3, you can definitely do that. Otherwise, if you are looking for free resources, if you're still skeptical that do I maybe you don't have 3,500 and you want to look up for free resources, you can go to codeforces.com. Okay, let me just 1 second, guys. Okay, codeforces.com, and when you go to codeforces.com, you can go to the educational section. Let me just log in 1 second, guys. And here in the ITMO thing, oh, let me just log in, guys. Give me 1 second. Oops, let me just log in through Gmail. And once that is done, you can see that 2 pointers is here. You have some practice problems. Apart from this, you also have practice problems on binary search. Okay. Shena says, will the live classes be conducted every day or alternatively? So Shena's, we have come up with a unique thing. So usually we have theory classes on weekends, that is Saturday and Sunday, so that you don't miss out due to your college work or due to your company work. Apart from that, we have problem solving sessions on weekdays, that is Tuesday, Thursday. We try to avoid it usually during contests, but if there are too many contests, we can't do anything. So to answer your question, we'll have theory sessions during weekends and problem solving sessions during weekdays. And also we'll be having daily practice problems. So every day you'll be given some problems to solve. Prince says, I'm a 2-star coder on CodeChef, and by doing competitive programming, I joined this course. Is this language independent? The teachings are language independent, but the resources taught will be in C++. But I think if you if you are able to understand what is being done, you can just pick up templates from the internet. Shitansu has put up his uh, username, so let's have a look at Shitansu's profile. So let me just type that out. KT Perry. Okay, very interesting choice of username, I would say. And let's have a look. Okay, so this is good. This is good. You have first thing is you need to give more context, but your growth is amazing. Like in just 1, 2, 3, 4, 5, 6, 7, like in 11 contests, you are able to get to pupil. So you're doing great. I would just say give more contests. I think that is important. And I would say see less editorials. I can see that you see a lot of editorials because only 20 are unsolved. So you're going on the right track. Solve more 1500, 1600 rated problems. Avoid solving easier now. And I think you should converge to specialist in some time. Okay, Sitanshu. Chandan says, I am in 6th sem. I have done DSA only up to certain levels. I have solved 160 questions, but only okay. So Chandan, why is this? Because you have solved a bunch of problems, standard problems, and you aren't able to come up solutions on your own. So what I would suggest is go to codeforces.com and start practicing rating wise. So even if you look at my profile, all right, uh, if you look at how I practice, my practice strategy is very simple. I take up any rating, I solve 50 to 100 problems in that rating, and I keep solving. And you can see that the last where I solved was 2200, and my rating when I used to competitive programming actively, it was master, which is 2100, which is right around here. So that is what I'm trying to tell you, that just you can start by 800, solve 100 problems, then go to 900, 1000, 1100, 1200, 1300, 1400, so on and so forth. Okay. I can understand, Sitanshu. Like it happens, just keep practicing, you'll be fine. With that being said, let's move on to the next profile, which is the profile of Akash. So let me just put that up. So Akash X OP. So great. Oh, so you are already expert on code forces. You want to reach candidate master. All right. Okay. Let's see your recent contests. All right. You have given div 3. You solve. Okay. So what I can see is that your math is weak. Okay. If you look at this particular thing, like if you look at this round, let's have a look at this round. And let's look at B. Okay. What was problem B? Problem B tutorial. If you look at the tutorial. Okay. So it's basically an observation based math based problem. So right now, what I would suggest for you is your math is something that you can truly improve on. And if you look at you have to solve div to D to get to candidate master. So for div to D, you would need to learn these topics, which is dynamic programming. Uh, you'll have to get to dynamic programming, segment trees, mathematics, and you will have to improve your thought process in general. So I would say that spend some time on math and you should be fine. Okay. With that being said, okay. So I very interesting. I started profile review and a lot of people started. So we'll take up some sessions. Uh, Atharva asked a question, so let me take that up. We'll take up Atharva's questions. Atharva says that I struggled in interviews due to communication issues as I couldn't express my thoughts clearly. Your way of explaining things amazes me, and I love your advice on improving this skill. So, what you can do, Atharva, is that you can actively try to explain well whenever you're so let's say you're doing practice for your interviews, right? What I would suggest you to do is whenever you're practicing a problem, spend some time and try to explain this problem, right? So you solved a problem, like you in your head you have the solution. Explain that, like, either if you are in a hostel, try to explain it to your friend. Otherwise, what you can do is you can explain, you can just assume that it's a person on your right, and you can explain that, okay, these are the things that we have to do, and so on and so forth. If you keep doing this for long enough, like if you do it for a lot of problems, you'll get more articulate. Like, I didn't get to this point where I can explain all of these things so easily just like that. I've been teaching from the past 1 year, 1.5 year, and initially I was bad. Like, if you look at my previous post contest discussions, or if you look at my previous, like, for people who were a part of previous TLE batches, when I wasn't an educator, I was just a doubt solver, my explanation was bad. So what you have to do is you have to actively take up explaining, and you have to do it for every problem, and I think you'll be good. So for the next 100 problems you solve, make sure that after solving the problem, you're you have an idea of how to explain it, and you try to explain it. Okay. The next question is, I'm doing Java full stack development and doing CP in Java too. Is it okay? It doesn't matter, Atharva. Like, if you are comfortable in Java, go ahead with doing competitive programming in Java. The only thing is that you'll need a fast input output buffer reader. So you can look at second threads template and use that. Apart from that, you should be fine. Like, to get to candidate master, I don't think language plays a big role. After that, maybe yes, but let like even after that, a lot of people have used Java, got into legendary grandmaster. So if you are doing other things in Java, feel free to use Java for competitive programming. Okay. Okay. So a lot of profile requests have been coming in. I'll be taking 3 profiles more. Okay, guys, and then we'll conclude. Let's look at which 3 they are going to be. Okay. Let's take one which has been requested for a long time. Let's take up this. Okay. It's Roby Whitey. Again, interesting name. I don't know how you guys come up with interesting names. Mine was just Q. So Roby. I don't think this is a profile. So okay, this is underscore. Yeah. All right. Oh wow. Hmm. So why is that after? So I can see that you have solved 200, 800 level problems. So I would suggest to you that you solve more higher rated problems. This is the main issue right now why you are stuck at, let's say, 800, because the problems that you solve are of 800 rating. Solve, I would suggest solve 1100, 1200, 1300. If you go on to get to pupil, you should be able to solve of that rating. So solve 1100, solve 1200, 1300, and you should be fine. Exactly. Apart from this, let's look at Okay, there's a lot of spamming. Oh my God. I'll pick up two more profiles. And before that, let me pick up one question which is not related to profiles. Which tech stack project did I make? I have one project in Django and I have one project in Mon Stack. Okay. I have two good projects in Django, but in my resume, I have put up two projects. Okay. One in Django, one in Mon, and I've also added my Google project in which I worked on Golang. Uh, okay. With that being said, I'll take up two more. Okay. There is a good question, like along with your profile, if you have a question, I'll take it. So if you look at this, it's Destroyer 8935. 8935. So let's look at this. Okay. So first of all, you'll have to bring up consistency. If your exams are over, I would recommend that you solve more. With that being said, you have solved. Okay, so you can see that you have solved less of this. Exactly. So this is the thing that you guys are um, missing out. You should solve more of higher ratings. If you solve more of 1300, 1400, 1500, you'll be fine. Like you'll converge to that rating. Trust me. And you should have less of these breaks. You can see that 2-3 months you didn't do competitive programming. Again, 2 months there have been no competitive programming. So try to avoid this. And I can understand this is maybe where you have exams, here you have exams, but try to solve as much as possible and avoid these big breaks. You can have small breaks in between, but avoid big breaks. Okay. How much CP to do during exams? I'm not going to recommend how much CP you should do during your exams because I don't want you guys to fail. CGPA is important. So you can take a call for yourself. If you've studied well, you can do competitive programming. If you've not studied well, focus on your studies, get a good CGPA, come back to competitive programming, do competitive programming. Okay. Okay. Now, guys, I want to take up one profile, but I want a good question along with like what you want to be answered. Like I can see a lot of profiles. I'm going to take up one of them, the one which is the best. Someone says, please get to master again. Definitely, I'm going to try to get to master again. I definitely don't enjoy being at candidate master from when my peak was master. So I'll definitely keep trying. Thanks for your kind words. Uh, okay. So Legendary Catcher says, I'm stuck at candidate master trying to become CM, trying to become master. The thing that is different between a master and CM is you're able to solve div to ease. So I suggest solve 2300, 2400, 2200, and you should be able to get to master like 2100, 22, 2300. If you're able to solve div to E in contest, you'll get to master. Um, okay, let's look at uh, okay, let me pick up one last profile. 1 second, guys. Okay, one second, guys. Oh my God, too many profiles. But someone asked something around a template. Let me just find that. Is it okay to use templates as in real interviews? You don't have templates, so it's definitely up to y'all. What I would suggest is that, like, it's upon your personal preference. What I did is, if you look at my solutions on Codeforces, if you look at if you go to my submissions and you pick up any random submission, you will notice that my solutions are very clean because I do not personally use a template. Like if you look at my solutions, let me just, okay, this is not accessible maybe. Okay, this is accessible. None of my solutions have a template within them. Like basically when I got to expert, I stopped using template, but definitely it's your personal choice. For interviews, yes, you cannot use templates, but for competitive programming, it doesn't matter. Okay. Uh, Okay, let me take up two profiles. I'll take up Tushar Khandelwal and Arman Singh's profile. First, I'll take up Arman and then I'll take up Tushar's profile. These are the last two profiles we'll be taking up today. I hadn't expected this to be a profile review session, but it's fine. Like anything for you guys. So you used to, oh, you need to solve more problems. Solving 100 problems is good, but it's not enough. Like you can see that you have solved 70 rated, 70 800 rated problems. So again, it's same thing, guys. Just solve more problems of higher rating in your practice and you'll be good to go. This is one of the things that I'm seeing. And last profile, uh, which is of Tushar Khandelwal. Let me just pin that. So after spamming it 100 times, you finally got. So let me just put it up. Tushar 888. Oops, Tushar 888, not 88, 888. Okay. So you are pupil. You have been solving a lot. You want to get to specialist, and this is exactly same thing, right? You want to keep solving more. So okay, you solved less of 1300, solve more of 1400, 1500, 1600, 1700, and you will be fine. Like the majority things that I'm seeing here is you guys haven't practiced enough. Like with three, like you are trying to maintain consistency, but which problems are those is something that matters. I think you've been solving 1500 for quite some time. Since you have a break now, try to grind out 1500 completely, 1400, 1600. And for topics, I would suggest you go to edu, and here you learn these topics. Like you learn binary search, you learn two pointers, and once you have done all of that, maybe you can learn trees, graphs, and then you can learn DSU and segment trees. So first you can solve more 1400, 1500, 1600 questions, and after that do binary search and two pointers. Okay, these are the things that we would be taking up today. And what's your words per minute? Mine same 70. I don't write that fast. Apart from that, let's look at some problems. Like we are done with the profile review sessions. We can have maybe one more later. Like we can have more live sessions like this if you do enjoy them. Put up in the comments, like after the live, put them up in the comment section that we want more live sessions like this. We'll definitely take them up. Uh, 1 second, guys. The pace is too much for me to take up. Let me take up questions one by one, and in a couple of minutes, we'll conclude. Okay. Hey, Gaurish, why did you suggest me to see less editorials after looking at unsolved problem part? I didn't get that part. So basically, since you have very less unsolved problems, it means that whenever you look at a problem, you look at the editorial. That is not always good. You can see that you weren't able to grow. So now you can just try that you don't look at editorials that often. You only look at editorials when you're actually stuck. So this is something that I recommend to a lot of lower rated people or people who are trying to get or just starting out, that stop looking at editorials for a while and keep solving. And after you're stuck, like dead stuck, like you are sure that you are won't be able to think up anything, like think for an hour, 1.5 hours, and if you're sure you can't proceed, only then look at the editorial. That is why I say that you don't look at editorials. The next question is, can you tell the most encountered topics in Div 2 AD? And uh, okay, so A to D, like so we have made our course that way. So if you look at all the topics here, these are the topics that you'll find in A to D. So DP, graphs, trees, sparse tables, segment trees, binary search, two pointers, mathematics, greedy, hashing, tries tries maybe less frequently, but they do occur. Like bit tries has occurred a lot of times. Apart from that, number theory, bit manipulation, advanced sorting, prefix sums, STL, all of these things do occur. Also, you can look up at CSES. CSES is a good problem set. You can solve problems, like I used to practice for ICPC through this. So you can definitely look them up. Tushar says, Tushar got a mail from TLE through what uh, topics? I'm not sure about this. I will definitely get back to you. You can reach out to me on LinkedIn or Discord if you are on the course, and I'll definitely look into it. Okay. I think that is more or less it for today's session. I would definitely love to take up more profiles, but it would be unfair if I take up one and not the other. So we can definitely have more profile review sessions. I hope you guys understand. Uh, Last question, Kirtan says, I'm in fifth sem and my placement is after sixth sem. I have started CP. Am I late? No, you are not late, but I would suggest, like, if you're in your fifth sem, sixth sem, wanting to get a good placement, okay, uh, do competitive programming. That is very important because online assessments are going to be there on campus. So you need to crack them. But apart with that, you're doing competitive programming. Make sure you have two good projects which you can explain, and with that, also make sure you have done the standard problems because you don't want to get stuck only doing ad hoc problems. So if your target is to get a good placement or something like that, do competitive programming, give contests for your practice, do a lot of data structures and algorithms, and have good projects. If you have all these things, CS fundamentals you can learn later. That is not a big issue. But you have these things, you will be good to go. Okay. So that is more or less it for today's session. I can see there are more uh, questions, but due to time constraints, I'm unable to take them. I'm sorry. I'll definitely try to take them later. Thanks a lot for joining in. I hope you guys had a great time. See you guys next time. If you did enjoy the teaching, check out our courses. If you did like the session, do drop a like below. See you guys next time. Till then, bye bye. Thanks a lot for joining in. I hope I was able to provide value to your time. Okay, guys. Bye bye.